Welcome to Pavinars. My name is Andrew Bram, and today we're briefly going to talk about the ruggedness of laboratory tests for asphalt mixture cracking resistance. So the purpose of this research was to recommend cracking tests, and they recommended these cracking tests through ruggedness testing using ASTM E1169. When you do ruggedness testing, you're asking the questions, what factors influence measurements? And for this study, they used 2 levels per factors, and factors can be sample size, test temperature, loading rate, those type of things. And if you look at the image on the right, these were the factors for the DCT, or the disc-shaped compact tension, which included specimen thickness, notch depth, location of loading hole, air voids, crack opening rate, test temperature, and specimen conditioning time. And what you do is you take each one of those factors and have a high and a low level, just slightly different, and you can see which one of those influenced your final measurements, which in this case would be fracture energy. They explored 10 total cracking tests. So the ASTM tests they explored included the DCT, the disc-shaped compact tension, the SCB J sub C, which is the semicircular bend test at intermediate temperatures, also known as the LTRC method, and then ideal CT, which is the cracking tolerance index using the indirect tensile cracking test at intermediate temperatures. They looked at several ASHTO tests, including SCB-LT, which is a semicircular bend geometry at low temperatures, the SCB-FI, which is a semicircular bend flexibility index test, or IFIT, out of the University of Illinois, the BBF, which is the bending beam fatigue, and then 2 AMPT tests. Both the AMPT tests stand for Asphalt Mixture Performance Tester, and that CF is the cyclic fatigue test, and the LS is the normal sample, and the SS is the small specimen. Then finally, they also had 2 other tests, the overlay tester and the University of Florida IDT test, indirect tension test, which is OT and UF IDT respectively. And you can see all of these specification numbers are listed there as well. I do want to note, depending on when you're watching this, if you look at those ASHTO specifications, if there's a TP, that P stands for provisional specification. So in the future, that P may be dropped, and there may be a different number associated with the test. So just beware if you're watching this a little later, you may need to search for a new number depending on the test. So what the researchers did is they considered these levels of factors, and they tried to correlate these levels of factors with field performance, sensitivity, repeatability, completion time, equipment cost, adoption, and funding. And through this correlation, they would be able to recommend cracking tests. So some of the major findings, they did find that there are significant factors found for each test. And then they had 3 levels of recommended for field validation. If there is sufficient funding, all 10 tests should be evaluated. That's always a good academic finding. But if there is constrained funding, they recommended 7 tests, including the DCT, the SCB J sub C, ideal CT, the flexibility index, bending beam fatigue, and overlay tester. But then either the AMPT CFLS or the AMPT CFSS. So not both those, just one. So the 6 tests in the first bullet, and then 1 of the 2 tests in the second bullet. Now, even more interesting is how they categorize the extremely constrained funding, because the DCT tests stood alone. That is one that they recommended regardless of the level of funding you have to field validate. Now, for the intermediate temperatures, they recommended either the ideal CT, the flexibility index, or the overlay tester. And then for fatigue, they recommended the bending beam fatigue and then the 2 AMPT tests, but just one of those 3. So the DCT, one of the 3 in the second bullet, and one of the 3 in the third bullet. And they also had multiple proposed revisions for the 8 cracking test methods. So 8 of the 10 cracking test methods, they actually proposed changes to the specification to have a stronger and more robust specification. Now, I just briefly went over this report. There's a lot of good content in here. You can either Google NCHRP report 987 if you want to learn more, or there is a link down in the description section below.